Good afternoon, everyone. So this presentation will cover the new items for the Intraplex product line for the NAB 2016 show. So at the booth, we will have pretty much all the products available, from the product line for demonstration. There are a number of new introductions this year. On the products front, we are introducing IP-Link 100P and IP-Link MPX. Besides the new products, we have a number of enhancements and features on the existing products with new firmware version for IP-Link, HD-Link, Live Look, as well as NetExpress. Another introduction we are doing this year is a 30-day trial capability with the IP-Link features that require a feature key. So the new software version will be shipped with a 30-day trial capability for the customers. So the platform continues to expand. IP-Link 100P is the new single-channel full duplex model similar to IP-Link 100, but it has the front panel display, the detail VU meter, LEDs, and GPS timing capability for Synchrocast. IP-Link MPX is the new product that enables transport of analog FM composite multiplex signal over IP. So there are several benefits of transporting MPX in some use cases. It enables users to co-locate their baseband processing equipment such as audio processor, RDS generator, etc. at the studio side where the engineers are. You can also save on CapEx in cases when you're distributing the same signal to multiple sites. For example, for SFN application, because you only need a single set of equipment at the studio side, which in turn simplifies Synchrocast operation because the baseband processing delay across those equipment is common to all the sites. You don't have to go and measure the delay and compensate it separately. So there are two modes for MPX. The digital FM MPX is also referred to as AES 192. This is already supported in our other IP-Link products, IP-Link 100, 100P, and 200 as software configuration. Analog MPX required a new hardware support and therefore the introduction of IP-Link MPX. Now with this introduction, we round out our capability of distributing FM composite signal. As far as selecting between AES 192 and the analog MPX mode, if your exciter supports AES 192 interface and there is a sufficient STL capacity available, AES 192 is a way to go because it provides better signal quality because of the all digital path. So this is a full duplex product. It's got a front panel display as well as detail VU meter LEDs and GPS timing capability in the back for Synchrocast operation. It does have flexible sample rate configuration based on the FM services you want to transport, so you can optimize the WAN bandwidth. There are two SCA input ports to mix those channels in the outgoing MPX signal. There are two inputs and two output ports for MPX signal for redundancy. The system also has the capability to decode the main audio and RDS from either the input or the output MPX signal. And similar to IP-Link, it has the same capability with respect to the GPIO contacts and the network reliability feature set for reliable transport. There are four feature keys for MPX. Stream splicing, Live Look, and Synchrocast are same as other IP-Link products. Dual MPX port is unique to the new product and it enables the redundancy on the input signal. So on the input side, the system will automatically fail over between the primary and standby. Each input signal has independent level settings. On the output, both those ports are active simultaneously. Each output port also has a independent level setting. The SCA channels can be mixed into either of those output signals or both of those output signals. This is user configurable. The decoded main audio is put out on the XLR ports on the back, on the left and right, so it is stereo separated, as well as the front monitor port. The RDS information is displayed on the front panel display as well as the web interface. So with analog MPX mode, we support 3 sampling rates, which should be configured depending on the FM subcarriers, subcarrier or the services that you want to transport. There is 3 sample size resolution for each sampling rate: 16 bits, 20 bits, and 24 bits. 16 bits provides acceptable performance and provides about 90 dB of dynamic range. 20 and 24 bit will provide you few more dB additionally with a higher data rate requirement. So the table here for analog MPX shows the different configuration for that application. The boxes that are shaded in blue are the modes that can be transported over an RF-SDL using IP-Link's new data mode capacity. So to transport main audio and RDS, which is the most common configuration, you need minimum 2.2 megabits per second and maximum 3.2 megabits per second with 24-bit transport. To transport up to SCA1, which is what AES-192 transports, you need minimum 2.7 megabits per second, and to transport the entire 100 kilohertz spectrum, you need 3.6 megabits per second. Now AES-192 transports up to SCA1 subcarrier. The data rate for AES-192 depends on the sample size resolution that's configured. 24 bits is what people generally use. It does provide transparent mode. It requires 4.7 megabits per second. 16 bits provide acceptable performance, and it has significantly reduced data rate requirement. So let's look at some key capabilities of the IP-Link platform, starting with network reliability. Now, these feature sets are common, for all the IP-Link products, including the IP-Link MPX. And it starts with 3 network ports that are available for streaming and management, stream splicing with time diversity and network diversity to protect against packet losses, forward error correction to recover lost packets. So this is an added layer of reliability on top of stream splicing. If you happen to lose a packet, forward error correction can recover those packets. On top of that, we have automatic failover between primary, secondary, and backup sources with several options for backup sources to cover all different scenarios. So this is yet another layer of reliability on top of stream splicing and forward error correction. We also have very deep receive buffer. 512 packet buffers per stream are allowed to be configured. So depending on the packet time, you can have several minutes of jitter tolerance if you need that. With release 2.5, we are introducing 2 new features: automatic adaptation of receive buffer. With this feature, the system will automatically adjust the size of the receive buffer based on the continuous measurement it is making for jitter and network. So it will react to the changes in the network condition to enhance the reliability. An on-demand backup stream allows the receiver to automatically call those secondary and backup stream when they are needed, as opposed to having them always on and using up the bandwidth on those backup connections. So this is targeted for users with pay-per-use type connections such as LTE. So this slide shows the IP-Link's capability to scale the packet loss protection based on the number of networks you have and the quality of the network you have. So for example, if a user has a single network connection over a private network or a managed service type network, you tend to see isolated or random losses because it's a well-managed network. Forward error correction is going to be the most efficient and effective way to protect against packet losses in that condition. If you're using a public network, you tend to see burst losses as well as random losses. For burst losses, forward error correction is not as effective. This is where the user has the option of adding additional stream to the group with a programmable time delay, and that time delay can be recommended by the Intraplex live look based on the burst analysis. And if you have more than one network, you can add additional streams to the group for each available network. So this way you can scale the protection between your 2 IP links with having streams that are time diversity, network diversity, and forward error correction. So this slide shows IP Link's capability for primary, secondary, and backup switchover or failover capability. These sources can come from the same IP link encoder, maybe over a different network connection, backup network connection, or the sources can come over from a different IP link encoder located somewhere else. The sources can also come from a third party encoder, maybe a software running on your tablet or smartphone using the SIP protocol. And now with release 2.5, it can also come from an internet web streaming server using a shoutcast receive streams. When you lose complete network connectivity, the system has the ability to play from the USB playlist or a locally fed audio signal. So looking at some of the other key capabilities for IP-Link on the encoding front, pretty much all the algorithms that you see there are supported by our top tier competitors. Opus is the open source algorithm that's been getting a lot of traction, and even though it's open source, the quality of the software implementation does affect the audio quality, and broadcasters that have done testing of Opus using different codec vendors have told us that we have the best sounding implementation. But by far the biggest differentiator with encoding is the multi-coding capability or a transcoding capability, which allows the same content to be encoded with different algorithms and bit rate simultaneously, which opens up a lot of different use cases for IP-Link. Interoperability is also very important now for the customers. IP-Link supports standard protocols and standard algorithms, which allows us to work with other hardware and software codec vendors. Being able to transport control along with audio is also critical for a lot of the broadcast application, and IP-Link has the capability of transporting both GPIO as well as aux data aligned to the audio spurt. So this slide shows the concept of multi-coding. Typical IP codec vendor will be able to generate multiple streams to different IP destination, but all those streams will be encoded exactly with the same algorithm. With IP-Link, those streams can be encoded with different algorithms. So for example, you can send an uncompressed stream for your terrestrial users over the STL, at the same time send few compressed streams of the same content for your web listeners, or you can send a high fidelity stream over your main network and a low fidelity stream over the backup network across the STL. So this slide shows the IP-Link's capability of transporting control and aux data aligned to the audio spurt. Now the aux data can interface IP-Link either via RS-232 and now via UDP messages. So since the control data, that is GPIO data, and as well as the aux data coming from the RS-232 or UDP are packaged in the same packet along with the audio data, they go through the same treatment, for jitter as well as network reliability. We are also introducing audio loudness and leveling capability that is integrated into the encoder. This algorithm conforms to the EBU and ITU standards. In the television world, the standards are used for the COM Act to have consistent loudness between programming and advertisement audio segments. In the radio world, it's primarily targeted for the web streaming application where the CDN is performing content replacement for local area insertion application. So in that case, the audio coming out of the encoder needs to have consistent loudness so that can easily replace a segment. We are demonstrating this capability at the booth, so you'll be able to hear the variation in the audio loudness before and after it's been processed. So with the introduction of Shoutcast receive streams, it enables an end-to-end distribution of audio using content delivery network. We support 12 Shoutcast and IceCast streams. So on the encoder side, you can send several streams to the primary server and several streams to the backup server for reliability. The built-in transcoding and multi-coding capability allows the encoder to send multiple streams of the same content, which will save you on cost for that service from the CDN vendor. The encoder also has the dynamic metadata insertion capability and the optional EBU loudness algorithm capability. On the decoder, the biggest value add that we bring is reliability. The decoder has the option of configuring 3 sources for reliability: primary, secondary, and backup, and it will perform the failover and reversion based on the state of the servers. So Intraplex Live Look is our PC application that performs packet loss analysis and recommendation on which mitigation technique will be most effective on a network connection. It also has a long-term capability, so users can track the SLA if they're using an ISP-based service. And now it has email notification with the latest software version. So the users now have options of getting email alerts when the receive stream experiences alarm conditions. IP-Link Scheduler is also a PC application. that is used to send scheduled commands to the IP-link streams. It's primarily targeted for program switching based on time of day and day of the week, but you can also use this software for adjusting the protection of an audio stream based on the report generated by live look. So if the live look indicates that there are congestion or a packet losses between 5 to 7 in the evening, you can use this tool to program a different coding rate, reduce coding rate, and use the additional capacity for protection. So essentially you can enhance your reliability using this tool. Moving on to HD-Link, there are two main capabilities, to remember here. Or one is superior RF performance that is enabled by the integrated 5 watts of power and LDPC channel coding. And second is backup capability. So should the RF link degrade, the system can automatically adjust the modem parameters, the QAM rate, and the channel coding rate to stabilize the link. And should the link completely fail, it has the option of sending the traffic over a backup IP path. We have a new version for HD-Link as well. Version 2.6 expands the data rate capability from 1.5 megabits per second to up to 3.2 megabits per second, depending on the channel bandwidth and the QAM rate. The benefit here is to be able to transport a lot more audio channels across the STL using the advanced IP link compression algorithm. So for example, if you use Opus at 128 kilobits per second, with 3.2 megabits of HD-Link throughput, you can send up to 20 stereo channels. So the idea is that by using IP-Link along with HD-Link as IP radios, it enables the advanced capabilities of IP-Link, such as compression algorithms, networking, synchrocast, etc. So this slide shows IP-Link being used with HD-Link for a synchrocast application for both analog and AES audio, as well as for analog FM MPX signal type. Moving on to the modular NetExpress and multiplexer product line. These products have the ability to transport voice, data, and program audio services depending on the channel cards that are installed in the chassis. All the products accept the same channel modules. The difference is the network interface card. NetExpress is network interface card interfaces with both T1 and IP network simultaneously. NetExpress LX interfaces with IP network only, but it uses the same chassis as our T1 access server systems. So our existing T1 customers can easily migrate to IP-based network by simply swapping out the network card, so they get to save their investment in the chassis, the wiring, and the channel cards. We are introducing two new features this year for NetExpress and NetExpress LX. The first is the new GPIO contact channel module. So this card has 12 inputs and 12 output contacts per card. Each input contact is selectable between wet and dry operation. Each output contact is also selectable between normally open and normally closed. It uses extremely low bandwidth, 64 kilobits per second time slot. Usage can support up to 8 cards, so that's 96 contacts in, 96 contacts out, and it works across all the multiplexer platform, including the T1 access and E1 access servers. The other feature we are introducing is the automatic backup head-end capability for NetExpress and NetExpress LX. So with this feature, the remote site systems will automatically call upon the backup system should the main system fail. And because we use the wide area network for failover management, the backup system can be co-located or it can be located geographically dispersed. So thank you.